All right, so it looks like people are still coming in. I'd like to thank everybody for coming to my talk. So we'll go ahead and get started. So what I'm going to tell you guys about today are the Network Investigative Techniques, or NITs, that the FBI uses to de-anonymize users that are on websites like Tor. So if any of you listen to podcasts, there was a recent podcast by This American Life talking about no coincidence, no story. So coincidences are kind of how I ended up here. Right, so, just a little bit, I'll talk a little bit about me. So when I was little, I grew up on a farm in rural Nebraska. We did not have a computer, and I can pull myself out of a drawer. And when we didn't have a computer, right, I didn't know how to do anything. When I was 12, the grocery store had a giveaway. They gave away a free computer. All of a sudden, I had access to a computer. And so I did well in school. I went to the University of Nebraska at Kearney, got my undergraduate degree. There I learned a lot of computer science, right? So that is my background. I know a lot of you here are not computer scientists, but that's what I did. And then I got a job after I got my PhD. Okay. All right. All right, so after I got my PhD, I moved to a university called Dakota State University in South Dakota. And again, I was a computer scientist. And they said, hey, we need somebody that can do reverse engineering. So I said, sounds great. So I went to a black hat training. I learned how to do some reverse engineering. And then one of the faculty came up to me and said, hey, I have this case where a guy named H.D. Moore, who at that point I had never heard of, kind of famous apparently, he was unable to testify because there was he was being sued by somebody, and there's legal issues if you're being sued. So they said, would you be willing to come look at this NIT code? And I said, all right, that sounds great, right? And from that, right, that coincidence, as I was there at that university at that time, all of a sudden, I became this expert witness that has been used all over the country. And again, it was all sort of out of coincidences. So what do I do? So I help lawyers in order to figure out what all of this digital evidence means. I mean, you guys think about talking to a noob about, how to configure a firewall is hard. Try talking to a lawyer who is 50 or a judge who is 70. Right? So you have to learn how to talk to that kind of person, right? So you have to speak in analogies. Like I can't say, oh, the NIT, made a socket connection, right? That's going to have no meaning for them, right? So I have to talk about it in terms that they can understand. And so what I do is I determine what digital evidence we have, and then I analyze that and say, okay, what do I have? What do I not have? What does this mean? In a way that they can understand. And then I write reports that get included in the court, right? So they include those such that they use that when they are making their decisions for all of the pre-trial motions that I have been used in. And so these are some of the cases that are finished, and therefore I can list which ones that they are, right? So you'll see USA versus Cottom at the top, and Michaud, which is the second one. Those are the two ones that we will be looking at here. So for those of you that don't know, right, so previously the way the world worked is that the law enforcement had the ability to do things like get phone taps, wiretaps, right? So those were legal ways that they could listen in on conversations. If a website was hosting illegal content, right, they could make a request to that website saying, who are the users that connected to you? What are their IP addresses? Peer-to-peer file sharing is similar to websites. You just get on the network and you can see. And then you get a search warrant, and that is based on what area you're in, right? So if you're violating federal law, then there's a federal jurisdiction which a judge can issue search warrants. And again, some of the basics, right? So here we have Tor, right? So Tor makes it so that a client, a web server, right, doesn't know who its clients are. It doesn't know the IP addresses of them, right? So that is one level of anonymization. And then we have the second one, which is the Tor Hidden Services. So I don't know what the server's IP address is, and the server doesn't know what my IP address is, right? It bounces through the Tor network. It's all encrypted like onions, which every time I hear that, I think of Shrek, right? Donkeys are like onions. And so there's lots of layers, right? So to find these hidden services, law enforcement has to get lucky. They have to have a misconfiguration, or they have to get a tip that somebody is doing something illegal, and then they can find where that server is. And so once they do that, then they have to get a warrant, and they need to then try and figure out exactly where that server is, get a warrant to search that server, and then try and de-anonymize the users that are connected to that. Again, Mr. H.D. Moore here is listed. Right, so he published this, the Metasploit decloaking engine, and at the time, right, he posted it for a while and then had decided that it wasn't useful, right? Anybody who was on the internet was protected against all the techniques, right? So he took it off the website, right? We really didn't think about it much, but it ended up being used. And the case that I worked on was USA versus Cottom. This is nicknamed Operation Torpedo. Right, so there was a server that was located in Omaha, Nebraska. It was hosting illegal content, and then we had 3 different general methods of exploit that were used, and these are all based on the work that H.D. Moore did. And then it also tried to do DNS, right? So and I'll show that here in a little bit. And so what I was given access to the servers that the FBI had taken over, and then they had modified in order to deploy this NIT. So here I got examples of the code. So if we look down here, we can see this API gallery key. So this is a API key or a symmetric cipher. So it's using Blowfish, which is symmetric. We can see that over here we're generating the session ID, right? So it creates a session in PHP, and this is all backend server code, so the user cannot see this. And then if we look over here in the generate cookie, so there's a couple pieces of information on this line right here. So we can see data equals 1 at. So the 1 is implying that there were 3 different message boards that were used. So this is message board 1, and then there was 2, and then there was 3. And then we have a method, or what method did we use to de-anonymize them. And then we have their session ID, right? So the session ID is tied to when they log on to that website. And then the code down here, right, it says generate cookie. Well, it's actually using, as I said, Blowfish, right, in CBC mode. It has that key, and it generates a initialization vector, right? So the initialization vector is different for every user. You can publish that, but if you don't have the key, right, you don't have the ability to decrypt it, right? And this key is completely contained in the PHP code on the server. And then it does something, it splits it into 40 character segments with a dot in between them, but it prepends the IV at the beginning and then the encrypted text at the end. And so that's what it's storing. And then again, on the server side, it's trying to decide, okay, how should I exploit them, right? So according to H.D. Moore, right, there are different browsers. You try and exploit those different browsers in different ways. And so it lists here Firefox and IE, IE9, Chrome. It lists all of those in there. And then what it does is in this code right here, right, it's generating a cookie for each of these different types. Again, the types are to say, okay, what type of method did I use in order to de-anonymize them? So I got SWF and Java. The one I really care about is SWF. So the case that I was dealing with dealt with SWF, right? So that's the one that I got to investigate. And if you look down here, you can see that it's including a gallery.swf, and then right below that, it's setting a flash variable called ID to s_cookie SWF, which you can see above there, right, is the variable that exists in that array. Right, so it's got this cookie that's got encrypted data about what session was this associated with, right? So that's key. We're going to have to remember that. And then this is that SWF gallery. So One of the keys from this is that the FBI somehow lost the source code to how they created the NIT. I sat in court for like 4 hours listening to them tell each other how I put the CD on this disk, I lost it, they don't know where it went, right? It got lost somewhere. It's probably in some guy's drawer or, fell in behind it. Right, so what we were given is we were given that binary SWF file because that source code was lost. And so what I did as a reverse engineer, well, there's a library out to decompile SWF. It's called JPEG, which is the one I used. Right, it generated, as you can see, like we got random variable names, but you can go through and sort of read what the code does. So when it does the load gallery, it generates a domain name that is got an IP address in it, go figure, along with the cookie, which we'll look at in a little bit, and then it's cpimagegallery.com, right? So we've got this big long domain name that gets connected to. And the data that it gets is we've got, so this is a JSON file. Oh, I hit the wrong arrow. This is a JSON file, right? So we've got O for the operating system, X for the architecture, and then C for the cookie. And if you notice here, it says parameters.id, right? So that's that parameter that we set previously in the PHP code, right? So that encrypted cookie is stored in there, again, with that session ID. It goes and tries to make a socket connection. And so the thing that got missed with Flash is that it didn't use the proxy that was set for the browser. It made a direct connection out, right? So it's making a direct connection out, which is then getting the public IP address of the user who is visiting that Tor website, right? And as you saw, right, it generated a DNS name, right, that had that cookie in it. And so here, I generated a cookie, I ran it through the software, right, it would resolve that, right, so you would resolve anything with cpimagegallery.com, right, so if your resolver was set so that your DNS didn't go through your proxy, right, then you'd be revealed through this. Now, if your DNS did go through your proxy, then it wouldn't. Well, we've got more techniques. Right, so on the back end, and again, I was given all the code in this example, right? They used the Twisted Python framework. They called it Cornhusker because we're in the Cornhusker state. So, go figure, right? They're not doing very well this year, but we'll see. Right, but what it does is it sets up the domain for which it's going to listen to connections on, so that's that cpimagegallery.com. And the cookie key under there is that AES key that we saw earlier. All right, so when it would receive these requests, what it would do is it would do a bunch of different logging. So one, it would log to standard out or a log file, so that was one of the ways. And at the very end, we're going to see how this decrypt cookie works. But it would do several other things. So for example, in the Flash exploit, right, with a particular version of Flash, you had to have a policy file request, right? So the client would request the policy file for the site, giving different settings, right? So the FBI just had to return that to placate Flash to keep making the connection, right? So it would do that. And then it also, right, they would insert it into a database, because what better way to query all of the information about all these people that you de-anonymized other than to put it in a database so you can write an SQL query to figure out who it was, right? So all of that information got logged, the session ID, the board ID, into this database so that they could query it at a later point. And then here is, if you look on here, right, so I talked about earlier that where's my cursor? There it is. We can see that when it gets that request, it's going to go ahead and use JSON in order to parse it, right? So that cookie is stored with its key value pairs, which is the way JSON works. So it goes ahead and it does, a couple of checks. It tries to make sure that the cookie is there. It loads it, right? So if it doesn't have a key called C, right, that's for the cookie, then it's going to exit. If it does, right, it's going to go ahead and again, it's going to run this decrypt cookie, which then it will also log to the console or a log file. And then, let's see. Oh, this is, I think, just another example of where it's extracting the cookie. So we'll just go ahead and we'll get to the big one, right? So the decrypt cookie. So the decrypt cookie is going to, first of all, the cookie is stored in hex, right? So PHP did a hex conversion of that cookie. So it converted from actual hex into ASCII hex, right? It goes in, checks, and makes sure that the cookie has the correct number of bytes, right? So they have a minimum. It goes ahead and then uses the blowfish, and you'll notice here that it's got, so this is trimming off the first part, which is that initialization vector that we talked about. So that is the initialization vector that you need to feed into blowfish, and then the entire rest of the string is the encrypted cookie, right? And then it goes, and again, it does some sanity checks, right? So if there's a $sign in there, right, it's because it's got $signs as a delimiter to separate all the different parts. And then if it found them, then it goes ahead and it returns the ID of the board, right? So that's the 1, 2, or 3, the method in which it de-anonymized them, and then the last part was the actual session ID, right? And so they can, now they have that session ID, so they can tie the session of, I see the person logging onto the server to this site, and I can tie that with the IP address that I got out of this method of de-anonymization. So as an expert, right, I had to ask all of the technical questions to the FBI. And so, you know, one of the things is this NIT code is sent to some client at some point later, right, in maybe milliseconds. It's going to actually execute it. So we have some time delay between when the NIT is delivered to the client and when they receive that connection, right? So part of it is making sure that somebody wasn't spoofing, right? So somebody pulled it on somebody else's box, right? Copied it over and then ran it on somebody else's machine, right? So as long as that time is rather small, right, we can probably be pretty confident that what they did was legitimate. Now, if it's minutes or days, right, then maybe that becomes a little bit suspicious. And then we talked about, right, this exploit wasn't really complicated, right? It was published by H.D. Moore on their decloaking engine. So, but anybody could take that exploit and use it. So once somebody captures that traffic, right, then they have that ability. And we'll see that here in a little bit. All right. So that was Operation Torpedo. After that, right, I actually got contacted by somebody in Washington about, they had a case that had a different NIT. And again, coincidences, right? I'd done one, and then they looked at it and they said, hey, you've already done one, despite the fact that it didn't turn out well for your client. Hey, maybe you could do another one. And I said, okay, that sounds great. So the Playpen cases are all over the US and actually all over the world. I believe there's 100 to 200 of them in the United States. There were, I believe an agent testified there were like 100,000 across the entire world. So a majority of them were not in the United States. And so what the evidence that was collected and given to us as experts has been the NIT code, right? So the actual code that ran, and then a PCAP of the traffic which they received from that user that was de-anonymized. And once they had gotten that IP address, right, there's this entire process, right? These were in 2014, I believe, and I'm still getting calls on them today, right? So the process for judicial going through this is rather slow in comparison to a lot of things. But once they have that IP address, then they will go ahead and issue a subpoena to say we'd like to search so-and-so's residence, right? They'll collect all of their devices, and then check and see if there are illegal images on them or not. And then they will, of course, file charges if there are. And most of the work that I actually do are in pre-trial motions. So Operation Playpen, right? So Playpen was a website. It was hosting illegal content. And again, that case that I talked about, USA versus Michaud. So this is my best guess as to how the network investigative technique worked by the FBI. And you can kind of talk about a NIT as in one little tiny piece, right? This little piece of NIT code, or you could say the entire thing that they're doing is capturing data, and so that entire thing is a NIT, right? And so sometimes lawyers will get into we don't have all of the code related to the NIT is one thing a lawyer will say. And, that encompasses all of the different software. So we have a unique identifier generator to identify or create UIDs for each user that logs on. Right, we actually have to deliver it to exploit, and then the NIT, and the NIT actually has to be modified so that UID is included in it. And then all of that data has to be logged. And that's when a user hits the website, and then this exploit is sent to the client's computer, the exploit runs, and then the NIT runs after that. And the exploit could run anything, right, because it's running arbitrary code, and we'll talk about that. But then that data, like we talked about earlier, in this case, as in that one, goes over the regular internet, right, not Tor, bypassing all their proxies, right, such that it hits a government logging server. They log the IP address that is public, along with the unique identifier, and then they save that data to a hard disk so that they can come back 2 to 4 to 8 years later. That's how government works. All right, so another coincidence, right? I didn't actually ask them to do anything, but the ACLU, the EFF, and there's like a criminal lawyers association, right? They published this guide about challenging government hacking in criminal cases, right? And so one of my declarations was included in that as here is a model of how you would do it. Because honestly, lawyers have no idea what any of this means, right? They hear that they have somebody who's charged with one of these crimes, and they say, I don't know what the heck I'm going to do with any of this, right? So they call me and I say, okay, I've done this a dozen times, right? This is how it's going to go, right? And here are all the different parts that you have, and here are all the things that they've given you. Here are all the things that they haven't given you. What does it mean? What are your options as far as arguments that you can make to the court, motions that you can file? There have been other NITs, right? So one of the guys that was on the Michaud case was Vlad Tiskalovic. I don't know if I say that very well. Anyway, so he is very much in on capturing all of these. I'll take the V8. So he goes ahead and captures them. I don't know how this is going to taste. Chug, it smells awful. Oh my gosh. That is awful. Oh my gosh. All right, so this is from the same thread, right? This tbb payload.txt, the bottom half of it. Oh. All right, so one of the things that you'll notice here, right? So he actually annotated this, Vlad did, and you can see that this line right here, right? So this is the Win32 function resolver used by Metasploit, right? So when you deliver a payload using the FS pointer. Oh my gosh. Right, the FS pointer will point to the list of all the DLLs that are loaded. It iterates through looking for hashes and trying to find exactly what memory address a particular Win32 function exists. Right, so this is something that Metasploit uses. Again, this is used in one of the NITs. And another one was from the Giftbox server. This one actually connected to an IP address that was in France. And it's been listed here a couple times. And so when I am given this, the NITs and all of the code associated with those, I have to sign a protective order saying, I will not release this information. I will not disseminate it to anybody other than the lawyers who are involved in the case and the client that we have in the case. And generally, actually, the client can't even see it, right? We can talk about the evidence to him, but he ends up seeing my reports and not necessarily all of this because it really doesn't apply to him. And again, it's covered under protective order. So I cannot show what any of my NITs look like. but I can show different ones, right? So this is one of the ones that Vlad had done that was for a completely different NIT that was used. And so, you know, one of the things that I do is I go through and I will annotate the assembly code to say, okay, what exactly is happening? So for example, we can see WSA startup. Again, this is a Windows-based one. And then down here, we are making a call to WSA socket. All right, and that is, right, we're pushing all of the hashes on. We're calling EBP, which then is that function resolving function, right, to figure out where that is, right, so that it can execute that function. And basically, right, you load the binary code into using like PowerShell. You set a breakpoint, and then actually, when you get to that point where it actually jumps to the function, like Windows will automatically resolve that name for you and tell you that this is WSA socket, right? And then you can look up what are the arguments to that function. Right, and so I'll go through and I'll look at all of the different calls to all the different functions in there and say, okay, this is exactly what it does or doesn't do. Here's another function that is included, right? So we have hex to ASCII, so when you get a MAC address, right, you typically have that in hex, right, and so it converts it to ASCII, so that way it's easy to read when you're going through and reading the PCAP files, right, because it's a lot easier to read something that is in ASCII, right, so it goes ahead and you can see some sort of odd numbers, right, so 0, right, is 0 through 9, and then you see this 7, well, if you take 7, and if you add the character A to that in hex or 10, you end up getting the letter A, right? So that's how you convert the A through F values in there. Right, so this is a function that will do that conversion for us. And then, so one of the things that really bugs me about what the FBI will give me is that they will give me what's called a dead listing. Does anybody know what a dead listing in assembly is? So a dead listing is where you take an assembly file, a binary file, and you just start disassembling instructions, one after the next, right? And that's fine if all of your instructions are linear, right? And it just goes from top to bottom. But that doesn't actually work when you have data that exists within that, right? So a dead listing will try and turn each one of these ASCII characters into some instruction. So they're just asinine instructions that they'll give us, right? So when they give it to me, they give me the binary code, and then they also give me this dead listing, which is pretty much useless, right? I ignore it, right? I go ahead and I will load it up in, IDA Pro, and I will go and find all of the places where, right, these ASCII strings are, so like connection or accept encoding, right? And those will all be as instructions. I'll go ahead and I'll fix them so that they map to the right actual values. And then some of the interesting ones, right? So this is for the socket connection. We've got port 50 hex, which is port 80. And then we have a IP address down here, right? So that's the hex digits for an IP address, and I put in there the comment of what that IP address was at the time. And then we have our GET request, right? So the GET request, right, you're saying, well, that's a crazy URL that they're getting, right? That's actually a unique identifier, right? So that identifies who that was on the website, right? The FBI generated it, as I showed in that diagram, right? Each one of them gets a new one, right? So every NIT that they produce is unique, right? And thus, every single time I have to redo all of my analysis because every single NIT that they give me is unique, right? The hash of that is going to be different than the hash of each other one that I have. All right, so some of the issues that are involved. So how many of you have heard of Rule 41? Couple. All right, so Rule 41 states that a magistrate judge is has the authority to issue a warrant to search and seize a person or property located within their district, right? And if you look at what the FBI did, is they were in the Eastern District of Virginia, and they issued, at that time, a search warrant that basically covered the entire globe. Now, they can only get people that were within the United States, but they have the information about that. So now we've changed, at that point they had changed the way that they interpreted this rule. Now, these are not laws. These are rules that the district courts abide by. So all of the district courts, have a set of rules that they say, we're going to abide by these. And, if you violate them, well, we'll deal with that in court, and it doesn't get dealt with in Congress. And Congress actually had an opportunity in order to decide how Rule 41 would be changed. And they chose not to because our Congress clearly can't do anything at this point. All right, so this is the new Rule 41. So if we read through here, they can issue a warrant to use remote access to search electronic storage media and seize or copy electronically stored information located within or outside the district if the district where the media is located has been concealed through technological means. Right, and then there's another one, or another way, right? So if you are hiding because of technology, then they say that you can issue a warrant for anywhere, right? So any judge, local, state, federal, tribal, can issue a warrant for anywhere in the United States. I mean, maybe that's good, maybe that's not bad, but that's the way the rule has been changed. Now, in all of the Playpen cases that I talked about, they did not have that rule in place, right? So there have been cases that have been thrown out because a judge in a different district has said, well, I didn't sign off on this warrant, so I'm not going to allow that evidence to be included. Right? So they'll just throw it out of hand. There's only been a couple that have done that, but generally the judge says, well, the FBI did it in what's called good faith. So they said they weren't trying to circumvent the policy, but they said, how hard would it be to get a warrant from every single judge in every single district in the United States? Secretly and covertly, right? I mean, they're not telling anybody that they're doing this, right? So that would be difficult. So I understand their position. But we did have this rule in place, and they did violate it. And so that has caused some of the legal issues that we have. We also have the Fourth Amendment, right? It says you cannot be illegally searched and seized, right? And so one of the questions is, the big one is an IP address public? Is that public information? Now, you might say, well, when I connect to a website, every single website that I connect to knows what my IP address is. But you also have a reasonable expectation of privacy. So if I'm in my house, I have a reasonable expectation that somebody is not taking pictures through my window, right? When my house is on my private property. And so people who were using Tor, right, believed they had a reasonable expectation of privacy. Right, and this is the argument, right? And it's up to the lawyer that I'm working with in order to make a valid argument and see if that is one that the judge believes is true, right? And every single district is different, right? Every single time I'm having to deal with different issues because we have a federal case, but it's spread out all over the entire United States, right? Every place is different. And then these are pieces of information, right, that can be seized, right? MAC address, username, architecture. Right, we've seen some of those listed, and are those, is that a search, right? And they're really saying it's not a search, right? They were just collecting information and then using it. All right, so one of the things that I talked about is I have the NIT code, right? So that is the code that I have been given and I can go ahead and test. But I haven't been given the exploit code, and as you can see, right, the server is generating a random ID and then inserting it into the binary. And then it has arbitrary code execution, and it's running it on the client's computer, and they have the ability to do all kinds of things, right? If you look at some of the documents that have been released, right, we know that the NSA has the ability to log onto somebody's computer when they're on it, right? They have the ability to read any file, write any file, right? They have those abilities. And all I'm saying is you should give me the entire exploit so that I can just verify that you did what you said you did, right? I don't care. I don't think that you're lying. I just want to make sure that you're doing what you said you did. And that's my entire argument. And then one of the FBI agents said that, well, I ran it on my computer and it didn't change anything. I mean, you can believe that, right? And that's part of the thing, right? We have people who are doing illegal things, and we have the government, and the judge generally says, I trust the government to do things legitimately. And I generally trust the government, but not always, right? Sometimes they lie, but that's sometimes. I just want to verify that what they said they did is what they did. That's all I want to do. Actual issues are, what is the error rate? Like, how many times did it misidentify somebody? How many times did it not identify somebody? Like, you sent out a request and it didn't bring back anything. Like, what does that mean? Are there ones that you received that weren't related to any of the UIDs that you generated? Did you get multiple ones, right? Those are all pieces of information that I can't test and they aren't providing us with. And like I said, all that server software code, right, that's not included. So I can't look at that and say, well, if there's one operator that was pissed off at somebody, right, and ran something different, right, was that possible? Who had access to that server? Again, these are just questions that we have to go through and we have to answer. And one of the arguments is they'll do what's called in camera, or it's within the judge's quarters, right? So chambers, sorry. So the judge can be with their expert, right? The expert given by the government, and he can review this binary code. I mean, your laughter expresses it, right? So, you need to have somebody in there who is an advocate for the person who is being charged with these crimes. You can't just say, we're going to allow your expert to explain it all, right? Because it's already black magic to them, so more black magic is just going to be great. And also, right, we have this thing called protective orders, right? I've signed protective orders in every single case that I've done, and I haven't given out the information that I've been given in those protective orders. And they say, well, we're worried about you divulging that. I suppose there are hackers that could steal my code. But, right, I'm totally not going to do that on purpose, right? Because I can get taken into court, I can get sued if I release any of that information, right? So that's not what I'm going to do. I am more than willing to go to a government facility. There's one in Omaha that I can go to and review the code if that's what they want. And that's what we did in the Cottom case, right? I went to Omaha and I reviewed the code in Omaha, and I did not take the code out because me being in possession of that hard drive is against the law, right? I can get 5 years in prison, right, just for possessing the hard drive. So I don't want to take that hard drive home at all. So what I've suggested is that we should probably have a framework for testing all of these NITs, right, so that I can get the exact system that they had with all of the configuration files and who has access, and I can say, yes, I can indeed verify exactly what they did, right? Basically given the entire system configuration of that server, right? Are there known exploits that are used against that version of the server that they're running to allow somebody to have access? Who has access to that server? Who is making hashes of the log files to make sure that they haven't been altered to have somebody else's IP address in them? Right? All of that is relevant information, right? That if I'm going to legitimately run a test on this, right? I come from a software testing background. I worked 5 years as a programmer doing web apps and all kinds of crazy things at a tiny company. And so I know how to test software and how to see, are there bugs, are there problems, right? What are things that we could have, what are issues that we could have? Another recent case is Operation Downfall 1 and 2. So these are in relation to Tor Mail and Tor Chat, which got hacked. And we do have the statement here that the allegation that CMU was paid $1 million to hack Tor is inaccurate. It says it's inaccurate. It doesn't say it's not true. Yeah, if it's 1.1 or 0.9, right, then it's different, and this is inaccurate. Right, so SMU or CMU has not denied that they were paid in order to do this. And again, we haven't been given access to how they did it, although I believe they've published some papers saying that they have done research into timing attacks against Tor in order to figure out what the IP address of somebody who was using, for example, Tor Chat or Tor Mail was. But that one, I think they had egg on their face, right? Because there haven't been no federal charges as far as I'm aware of, and there have been some state cases, right? And these are federal crimes that they're committing, and you would wonder why they're not making federal cases for that. It's probably because they did something wrong, and then they learned, right? This happened before some of the other ones. And so I think they figured out they did something wrong. They decided they just scrap it, right? And they'll throw it down to state court, where it's a real pain because in state court, you can only question an FBI agent so much because they're given talking points to say, these are the things you are allowed to talk about in state court because we're not in federal court. And so it really hinders the prosecutor or the defense because we can only ask certain questions, and then he can say at any point, like, well, I'm not allowed to talk about that. Do I get information out of that? No, not really. And in a coincidence, actually this week, I got an email that was completely separate, so a completely new case that was where the FBI was using a NIT, right? So right now, they're using these in probably child pornography, terrorism, and drug cartels. But the thing is, they're going to keep using these, right, in more and more cases because this is the way people are hiding their information. And so we have to decide, is this a technique that we want to allow them to just deploy anytime and then just trust them or not, right? So those are some of the issues that we're going to have to deal with going forward. We're not going to have less of these cases. We're going to have more and more of these, and we also need experts out there who can take something that is very technical and describe it to somebody who is not very technical, right? And that's a real skill. I'm not saying I'm great at it, but apparently I'm good enough that they keep asking me to come back. And then almost lastly, anybody interested in reverse engineering, right? I created a bunch of challenges for the CTF here at Derbycon, and Dave gives lots of hugs. So if you guys want to do them, you can do them. If you have questions, you can contact me about them, and I will be more than happy to give you guys hints or help afterwards, but not right now. So people are still working on the CTF. And there's my contact info. Any questions? No, browser fingerprinting has never come up in any of these cases.
You mentioned DataPro. What other resources would you recommend for getting into reverse engineering, learning x86, x64 assembly, and tools and things?
So I've produced some courses on how to get started into assembly, first of all, and then reverse engineering. There's several books out there that you can look at, and they will help you through it. And I've tried, IDA Pro is expensive, and I've tried some of the cheaper ones. And for example, the data encode doesn't work